All right. Are you ready for your final exam review? Woo-hoo. I'm going to try and give you some pointers along the way in here. Again, if you get stuck on any of these questions or you want direction on some other ones to practice, feel free to ask me or just go back and look in those sections of the book for similar questions to work on. Because I'm going to go through this relatively quickly so we don't have a 3-hour long video. But I'm more than willing to go through something again or more slowly with you if you want. Okay, number 1, graphing. This is r equals 2 cosine theta. The easiest thing to do is to one, recognize from the equation what kind of graph it will be. And 2 is to make a table of values in order to graph it. This one is going to graph a line for us. So if we figure out theta and then whatever 2 divided by cosine theta is, I'm just going to run through 0, pi over 6, pi over 4, and pi over 3, just to give me a few. If I plug in 0, cosine of 0 is 1, so we get 2 divided by 1, which is 2. Pi over 6, we get root 3 over 2. 2 divided by root 3 over 2 gives me a cute little decimal of 2.3. Again, you can type these in your calculator. You would need to be in radian mode if you're going to type in radian values. If you want to type in degree values, that's fine. Pi over 4, we get 2.8. Pi over 3, we get 4. If you come in and graph these, then 0, we're at the point 2. We're going to do our best. Pi over 6, we go 1 ring, 2 ring, and a smidgen-ish. Pi over 4, we're at 2.8, almost to the 3. Look, if I just keep clicking, it'll get there eventually. And at pi over 3, we're at 1 ring, 2 ring, 3 ring, 4 ring right there. So, whoop, it graphs us a cute little vertical line. My hint here for you on this is to remember the circle equation. Like the equation I would give you that would graph a cute little circle around ring 2 or ring 4 or something like that. So remember the circle equation. Number 2, y equals 3 sine x. Okay, this is the graphing stuff we did in 24, I believe. So if you remember sine starts at 0, 0, and then goes up. The big thing you're going to want to do is remember these parent functions, where they start and what direction they go, so you can build your graph from there. Sine usually starts at 0, 0. We've got an amplitude of 3. That means I'm multiplying my y value by 3. 0 times 3 is 0, so my point stays here. Usually my sine, I guess I'll go put in my parent function. Here would be my parent function, and then we go up to 1, then here, then down to 1, then back here. Okay, those purple dots are where my parent function would be. At pi over 2, we're usually at a y value of 1. We multiply that by 3, then we go up here to positive 3. 0 times 3 would be 0. Negative 1 times 3 would be negative 3, which is off my graph. I love when they do that. And 2 pi times 0 would be 0. 0 times 0. 0 times 3 is 0. Wowzers. Okay, so then you can just draw in your cutesy little whoosh-doo. There, and get your graph in. I'm going to do a simple one. It's going to be a one-step problem on your exam, either multiplying the amplitude, shifting it left or right. Nothing too crazy. I'm not going to throw a period on there at you. You should know how to do that, but I'm not going to do that to you this test. Okay, 3, this is just the parent function, e to the x. It's an exponential function. It starts down here at 0, and then it increases exponentially. The other thing I might ask you about, hintity, hint, 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 is the log function. So f of x equals log of, wow, Swindell. Blah, 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 pretend like I didn't do that, equals log of x. Okay, that would be a base 10. If you were to graph this, it starts coming up from the y-axis and then whooshes out that way. Okay, so it looks that way. I think it looks like an upside down L. I've been told it doesn't look anything like an L, but I like to claim it an upside down L. That's how I've remembered it since high school, so you're welcome. I would know both of those. One of the two will be on your final. Okay, number 4, y equals tan x. This is the basic parent function. Like I said, know the parent functions of these sine, cosine, tangent, cotangent, secant, and cosecant. I'm going to pick one, not tangent, because it's on your review. So I'm going to either pick cotangent, secant, or cosecant and put it on your final. So remember where the asymptotes are on those. On tangent, our asymptotes are at the over 2's. So we'd have a okay, and tangent swoops up. It has a positive thing and lives at the origin. Nope. Nope. Okay, and there's your tangent. Again, I'm going to throw a parent function on there of one of those tangent, cotangent, secant, cosecant. So just remember where those ones go. Hey, look, we're through 2 pages already. Isn't life fun? Okay, solving for x. This is where the crazy stuff starts to happen. We here have e to the 2x minus e to the x equals 2. You need to be able to recognize that to solve this problem, you have 2 e to the x's. You're not going to be able to just get it by itself and solve. You've got 1 squared, 1 linear, so we're going to factor. This is where we did all those crazy factorings. So we've got e to the 2x minus e to the x minus 2 equals 0. When you factor, always set it equal to 0. In the book, they talked about changing the e to the x, saying e to the x equals y. So you could rewrite this as y squared minus y minus 2 equals 0. If it's easier for you to factor that, then come back and change your answer to have the e to the x's, by all means, please do. There's nothing wrong with that. Go for it. I'm just going to kind of show you what it looks like here. We're going to factor this. E to the 2x would be e to the x times e to the x. What multiplies to be negative 2 but adds to be negative 1 would be minus 2 plus 1. Because negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1 equals 0. So that's my factored form. Then when we solve this, we set each piece equal to 0. So we would, I'm going to come over here. We would say e to the x minus 2 equals 0. E to the x plus 1 equals 0. So e to the x equals 2. And e to the x equals negative 1. To solve and get our x down. So when we've got an x stuck in the exponent, we use logs or natural logs to get rid of them. Since our base is an e, we use a natural log. So if I come in and I do the natural log of e to the x, what I do to the left, I do to the right. That natural log drops away the e and makes my x come down. That leaves me with just x equals the natural log of 2. You're going to just type that into your calculator and you get approximately, you should be using the squiggly equals, but it's not one of my pet peeves, so we're just going to roll with it. Oh no, what have I done? Okay, come back, there it is. 0.6931. Over here, if we do the same thing, if we were to take the natural log, we would get e to the x. Just kidding, we would not get that. We would get x equals the natural log of negative 1. You cannot take the natural log of a negative number, nor can you take the log of a negative number, because if you remember my QL graph up here, somewhere, oh, that was on a different page, okay? There's no negative values for logs. The natural log graph is the same as the log graph. They look the same. So you can't take the natural log of negative 1, which means if you type in your calculator, you can tell you it doesn't exist, so this does not exist, or it's not valid. You would say not valid solution. So this is your only answer here. And you have to work the problems through. When you get an error for taking a log of a negative number, it's because you can't. It's not possible. Okay, number 6, solving to get x by itself. We want to get rid of the 2 on the bottom. We're trying to isolate x. Just be mindful of your inequality sign there. So if we multiply by 2, we get the square root of x plus 3 less than 2. If you remember back to middle school, the only rules that change this is if you multiply or divide by a negative number, that sign will flip. I'm not going to do that to you yet. Or yet. Not going to do that to you right now. Not what I'm working on. Okay, to get rid of the square root, we're going to square both sides. That leaves me with x plus 3 is less than 4. Subtract 3, x is less than 1. And you're done. Alexa's very loud. Real sorry. Number 7, we've got the absolute value here. It says the absolute value is less than -1. You have to think logically here. You could go through and do some work and come up with some numbers, but they're actually not true, because when you have the absolute value, by definition, whatever you get in here, you will change it to a positive number, and a positive number cannot be less than -1 ever. So there is no solution here. Okay, and then number 8, we've got e to the 2x equals 5. We want to get rid of the e and bring the 2x down. So we're going to take the natural log of both sides. That leaves me with 2x equals the natural log of 5. You can type that into your calculator and then divide by 2. So x equals the natural log of 5 divided by 2 is 0.8047. All right. Identities proven. Dun, 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 dun. You remember these? Now, you have a formula chart at the back of your worksheet booklet thing, the workbook, that's what it's called. You are welcome to use that. It has all those identities that we talked about. You are more than welcome to use that to help you. Again, I'm not going to give you the crazy ones. They're going to be pretty basic like these ones. So tangent, we can rewrite as sine over cosine times cosecant is 1 over sine. We want that to equal 1 over cosine. Well, you can see pretty quickly that sine over sine divides to 1. We're left with 1 over cosine equals 1 over cosine, and yippee skippy, it proves correct. That's all I need you to do is make the left and right equal to each other. Number 10, I'm getting out of breath. Number 10, this we're going to look at. First, let's change cosecant squared to 1 over sine squared. Sine squared of 90 minus theta. We didn't look at this one a ton. We alluded to it. But whenever they do 90 minus something for sine and cosine, because they're complementary functions, sine squared of 90 minus theta is the same thing as cosine squared. So we can just say times cosine squared over 1. Then plus 1 equals 1 over sine squared. Okay, so here we have cosine squared over sine squared plus 1 equals 1 over sine squared. Now, it erased it for me, which is helpful. Doing plus 1 is not helpful to us at all when we have sine squareds in both of our denominators. So we're going to be clever and change 1 to sine squared over sine squared. If you remember, your other identity says, so we could combine these into cosine squared plus sine squared over sine squared. Cosine squared plus sine squared was one of those big main identities. That's equal to 1. Our common denominators, I was writing the word common, not helpful. Boop. 1 over sine squared, throw my theta for good luck, equals 1 over sine squared theta. Yippee skippy. It worked out fine and dandy. Okay, so this was, I'm not going to put this identity on the test, but just know that it exists. Basically, we're looking at using sines and cosines, secants and cosecants, what those all change into. Remembering sine squared plus cosine squared equals 1, and the reverses of those, like we did before, 1 minus cosine squared or 1 minus sine squared, what those are equal to. Those are the main identities we're going to draw from in this test. Okay, I'm going to stop for this video.